Hi, welcome back to LeetCode. Today we discuss LeetCode problem 632, smallest range covering elements from key list. So the content of this video is, first I will explain the problem statements, then I will share some example how it's working, how you're getting the expected output, and then share the intuition to solve this problem. Then I will share the C++ code. Okay, so the problem statement of this problem is, you have k list of sorted integers in non-decreasing order. Find the smallest range that includes at least one number from each of the k list. And we define the range a comma b. We have to find the smallest range. So what is the smallest? Smaller than if we have two range a comma b and c comma d, two range, then if b minus a, whatever the length and whatever length of the range 2, d minus c, if it is L1 less than L2, that means it is actually this is first range is smaller. Then we have to take the answer will be a comma b, or a less than c if both length is equal, L1 equal to L2, but whichever starts first, it means smaller, start first, that is actually will be the smaller. Okay, so first of all, what they actually, for this example 1, here k is equal to 3 sorted lists are given. This is one list, this is second list, this is third list. So you can actually observe that first all the lists are actually sorted. Here actually 4, 10, 15, 24, 26. Okay, again from the list 2 also it is sorted, 0, 9, 12, 20. Okay, but in between lists are not sorted. Like first list is starting with 4, but this is starting from 0, this is 5. Correct, this is not sorted, but the within the list numbers are sorted in non-decreasing order. So we have to find out the minimum range that includes at least 3 numbers. 3 numbers, why? One number from the list 1, one number from list 2, and one number from list 3. That's why that our range should contain at least 3 elements, at least. Okay, so what actually the so go to the first example. 4, 10, 15, 24, 26, 0, 9, 12, 20, 5, 18, 22, 30. So one possible range is contain only 3 elements from 4, 0, 5. 4 from here, 0 from here, 5 from here. So what will be the range? Range will be 5 minus 0, it will be 5. Correct? Now any other possible? Yes, one possible is 10, 9, then 12. This is also 9. 10, 9, then 5, also 15, 12, 18. Yes, 15, 12, 18. So what is the range of this? 18 minus 12. So this is again 6. So this will be our answer, because this is actually smaller than this. Here actually length is 5, here length is 6. Now you can take another 20, 22, then 24. What is the range of this? 24, 20, 22. The range of this will be, what is the maximum value? Maximum value is 24, minimum value is 20. So this is 4. This is actually smaller than all of this, both of these. So our answer will be 22, 24. You can check also other pair of other range also, but this is the smallest. So that's why this will be our answer. Okay, the 20 through 24. Now what is the first approach you can actually think about this? First of all, I will have some range from list. Suppose this is our list 1, this is our range, and this is our list 2, this is our range, and this is suppose our list 3. Okay, so what I have to return? Actually ultimately I have to return the common, this common, this common, and this common. Ultimately we have to return this, because this covering, you can check, this covering some number from list 1, some number from list 2, and some number from list 3 also. Correct? This actually satisfies condition that at least one element from each list we have to contain. So this is one possible answer. So we have to find our intersection of all of this, all of the list of the k list. So then what will be the actually easiest way? So you can check our easiest way is to our range should contain at least k elements from k list, one number from each list. So go to this example, then it will be easy. Then our example first list contain 1, 5, 10, second list contain 2, 15, 20, 3, 25, 30. Okay. So first of all, what is actually if I want to contain only 3 elements, smallest thing. So what will be the smallest? This will be the smallest from the list 1, this will be the smallest from the list 2, and 3 will be the list from the smallest from the list 3. So our range or window will contain only these 3 elements, 1, 2, 3. Okay, then this actually contain 3 elements from 3 different list, correct? So what will be the range of this? Range of this will be 3 minus 1, 2. Okay, this is one possible answer. Now I've already processed this. Now next smaller will be what? I have already processed 1, so next smaller will be 5, because this is the smallest of this, all of this 1, 2, 3. So the next smallest will be 5. So this will be 2, 3, 5. Correct. 2, 3, 5. Now our current window contain only 3, 2, 3, 5. 3 elements from 3 different window. You can check 2, 3, 5. This will give the smallest range, smallest window. So total range of this 5 minus 2, it will be again 3. Correct. But this is not actually smaller than the previous, so this will not answer. Now what is the next smallest? After 2 it will be 15. 3, 5. This is 15 minus 3, it will be 12. This is not a smaller the number we have seen in the past, so that's why this is not our answer. In this actually you can check our window contain only 3 elements from 3 different list. Okay, and I will check what is the maximum value of this window and what is the minimum value of this window. Okay, that will be our range. If our range is smaller than the number or range I have seen before or the past, if it is smaller than that, this will be our possible answer. Else I will go to the next window. Correct. So I will start from the smallest number, 1, 2, 3, because this is actually the smallest number from the list, from the k list. Because this is sorted, this is also sorted, this is also sorted, this is also. So I will get the smallest number from the 0 index. Similarly, right? Then actually I will check what is the smallest, what is the range of this current content, whatever the window actually I have. I will check what is the range of this. Then I will go to the next window. Next window means I will actually discard this one from our window, because this is smallest. I have already checked. Next smallest is the 5. Correct. Intuition clear? And the explanation is also clear. You can actually solve this by, I have given the some hint actually. You can solve this by priority queue here, first of all. Then actually it is clear in the priority queue size will be always k. Why k? Because we have to contain at least one element from each k list. So that's our priority number of elements present in the priority queue will be k. Then I will check what is the maximum value present in the priority queue and what is the minimum value present in the priority queue. We have to find out this. Okay, you can first try to implement that. Then actually I'm going to the code actually. Okay, so first of all, this is a function. I will get one 2D vector for list k list. So right, so I am taking priority queue. What actually storing? I am taking a node, okay, vector of node, and compare function. Compare function, whatever the value actually I have, I am storing in the sorting the node with respect to the value. So I am iterating the nums vector. So index 0 will give the smallest value present in the ith list. Okay, so what is the minimum value and what is the maximum value? I am storing this. This will be what? Current. So for this example, 1, 2, 3, 5, 10, 15, 20, 25, 30. So current list, first list will be what? Will be the first list 1, 2, 3. This is the first window of k length. Correct. So that's why I'm just s min will give the what are the 1. This will ultimately store 1, and s max will ultimately store 3. Okay. That's why I'm whatever value I'm going to insert in this priority queue, I am checking what is the minimum value and what is the maximum value I have inserted. So I will insert the current value into the priority queue. What I am actually storing this? I am storing what is the row row means what is the list number, and the column, initially column is 0 because I am inserting the first element from each of the list. Okay, now our priority queue have only 1 2 3. Okay, now what I'll do, this is our possible answer. Minimum S min and max is the S max for this current window 1 2 3. So min will be 1 and max will be 3. Now till our priority is not empty, I can actually insert a new element or pop new element. So I'll just pop what it will pop. It will pop what is the smallest value in the window. What is the smallest value? It will be 1. Okay, I will check what is the value of this. Value of this will be 1. I'll check what is the maximum value. Maximum value is 3. And what is the minimum value? Current minimum value 1. Is this less than the maximum value I have seen till now? 3 minus 1? No. So I will not modify this. So after I have already popped 1 from our window, and I have to adjust this with the k element, right? So I'll check, is there any next element from this list? What is the list number? I will get from the row number. This current dot row, this will give the row number. I will check size is less than equal to the column. Column I will already store current dot column, right? Initially it is 0. Row number is the list number and column is the 0 initially. Now I'll check 0 plus 1 is less than equal to less than size. Then I can actually I have actually new next element. So we'll insert this into the priority queue again. Like after 1 I pop, so our priority queue will contain 2 3 and 5. Okay, 2 3 and 5 because this is the next smallest. And what is the maximum value? I have to adjust this. Maximum value is for what is the maximum value for this window. Maximum value is currently now S max is equal to now 5. Correct. This is you can check what is the maximum value of this range, 5. Okay, now what I am actually going to store, else it is break means I have already actually our list is actually one list is actually empty, so I can't actually check because this is already stored. Whatever actually range will it will actually increase. Correct. If there is no next element from this current one, any one list, suppose this is the list, suppose 1 5 2 3 5 or 15. Okay, now I have already checked 1 2. Okay, then I have already checked 5 2 because this is the next smallest after 1. Then now I have already checked, now it will be 3 5. Okay, 3 5 already checked. Now 3 will be popped, 15 5. Okay, this is actually already iterating. Now you can check actually 1 5 or only one element, 1 5 10 15 20. So first of all our priority can contain only 1 10, then it will contain 5 10. Okay, then after 5 there is no element. Can I actually adjust it to 2 element? No, because I have whatever the actually range actually I have 5 10. I have already checked what is the max, what is the range can be, minimum range, smallest range. So there is, because that's why we do not have any next element, so that's why our range will not be changed. So that's why I can break from here. Okay, else break. Correct. Now at the end our AS mean and max, it will store the final answer, starting and the ending of the range. So I'll just insert this into our answer vector. I have written this because our answer is expecting as a vector of integer. Okay, it is clear logically. I have actually transformed this intersection logic to in a linear approach that will contain only k smallest element from k list. Each one element is present from the k different list. Okay, first of all I'll check what is the range, what is the actually range of this. Okay, then I suppose I'll insert one element, then I'll check what is the range of this next k window, next smallest k window. In this actually I'll check what is the max, finally what is the smallest value, and at the end I'll return that start and end. Got it? Clear? If you any doubt you can actually comment on that. If you have any suggestion, you can also comment on that. And if you if the explanation is clear for you and if you understood the problem, please like the video, and if you not yet subscribe the channel, please subscribe the channel.